let's say we do input-output. Let's look at input-output in general, then we'll get to the input-output for our rat class. So let's say I have an integer I, and I has been declared, been assigned, initialized to 5. And I want to output it. So I say cout, and I say left shift, and I say I. Now what does that mean? So in fact, left shift has a meaning in C and in C++, fundamental meaning, which is shift the bits in some integer to the left. But it's been overloaded in C++ to be an output operator. So what happens is when the compiler sees this, cout left shift I, it immediately translates it into cout dot operator left shift I. Now that means, we know already the syntax, that cout on the left hand side is an object, and to this object is being applied a member function operator left shift and the parameter I, which is an integer, is being passed in. The question is, what kind of object is cout? So cout is an object of a class that's defined by the compiler called the OStream class. O means output, an output stream class, and that's how it does the input-output. It does the output by creating an object called cout, which maps to the screen, and whatever I put in on the right-hand side of the left shift operator, it gets put inside this object and eventually gets displayed on the screen. So if I were to go into the OStream class and look at the member functions, I would in fact find a member function called left shift. Now what happens when I try to do the same thing with my rat class? Right, let's say I do the same thing in my rat class, and so I declare a rat called x, and then I say cout x. Now on the surface it looks to be the same thing, but if you think about it, it would have to translate to something like this. It would have to say, well, on the left-hand side, I have a cout object, and to that I'm applying the operator left shift, and I'm passing in a rat called x. So this thing here would be a rat, and this over here would be an OStream object. The problem is we can't do that, because the reason it worked with an integer is because when they wrote the compiler and they wrote this out to the OStream class, they overloaded all the basic types. So that's why it can output an int and a char and a float and a double and so on. And even for some of the library objects like string, well, strings are a little bit differently, but certainly for the built-in types, it's in the class itself. But here, it doesn't know about that, because how did the compiler know? When they actually wrote the compiler, how did I know that I was going to create a new kind of object called a rat, so that they could have included this overloaded left shift in the OStream class? And it's obvious they couldn't have done that. So therefore, I still want to be able to do this, but I can't do it by using operator left shift as a member function, because when I use it as a member function, I have to, the object on the left-hand side has to be a member of my class. And since cout, remember my class is the rat class, cout is not a rat object, so I can't use an overloaded left shift in my class. I would have to do something like that. I'd have to say something like, well, take x and operator left shift, and then maybe pass the cout object in it. But that's crazy, because then I don't have to write the output like this: x left shift cout, and that would just be, I mean, that would work, but it would be crazy. That's not what you want to do. You want to write it in the normal way so that it looks like every other built-in type. So how do we accomplish that? Okay, so what we have to do is something like this. Remember beforehand, when we wanted to add an int in a rat, we said we wanted to add 5 plus x. So on the left-hand side we had an int, and so that would not work, right? It couldn't use the operator plus, which was a member function, because the left-hand side wasn't a class object, wasn't a rat. So we have to do something very similar over here. What we need to do is we need to overload the left shift, but to take 2 parameters, just like we overloaded the add over here, and it took 2 parameters. So here's what happens is I overload my left shift operator, but now it takes a parameter of an OStream object, right, which is cout as an example of an OStream object, and a rat. So when I write cout left shift x, so it's going to call this 2-parameter function. The cout is going to be the first parameter and be passed in as an argument for OS, and the x is going to be the rat object. It's going to be passed into the rat here called R. So once I do that, let's look at what happens inside the function. when the function says os left shift dot r left shift r dot n. So what's happening over here is, well, what is left shift? What is left shift? What is OS? So OS is, well, what did I pass in here? It was my cout object, so it's going to say, this is going to be like saying cout, and that's going to be applying the left shift operator on cout. And what is r dot n? Well, so r is x, so this is like the numerator of the rat6. So I want to point out two things here. First of all, how can I say x dot n? Right? This is not a member function, right? As we saw, this is a function externally that's using two parameters, and one of them is a rat, but it's not part of the rat class. In which case, how does something not part of the rat class, how does a function that's not part of the rat class have the ability to use a dot on my rat, right? Remember, the data in my rat has been declared private. So the answer is, if you look back at the declaration of the definition of the class, it declared the left shift operator to be a friend of the class. And when you do that, when a class declares a certain operation to be a friend, it basically says that when I pass in parameters of the class type to that function, like here I'm passing in a rat to that friend function, operator left shift, it can use the data, it can access the data members and the function members of the class as if this were indeed a member function. So that's how the dot works. It sort of bypasses the private part. And the second thing I want to point out is that when I say cout left shift x dot n, this left shift over here is a different left shift than the one out here. Right? The one upstairs here, this one in the definition of the function, that's one that has a left-hand side which is an OStream class, right? An OStream object like cout, and the right-hand side's a rat. Here, the left shift, this is the regular one that we use for printing integers, because cout, in fact, is an OStream object, but x dot n is an integer. So this is not a recursive function. It's not like I'm defining the left shift in terms of the left shift, because these are, in fact, two different functions. Okay, so now it goes further, right, and it wants to print r dot d. So I want to point out how this thing works. And to see that, we have to understand, why do I have to do this return OS? What's going on over there? Why should I return anything at all when I'm printing? I'm just printing. Why can't I return a void over here? So, and the answer is, I want to use this to accomplish something called chaining. Right? Chaining allows me to put many, many things in the output statement, one after the other, instead of having to call separate output statements. So let's see an example using the regular built-in types, and then it's the same thing when we use class objects of a particular class type. So let's say I declare an integer I, and I initialize it to 5, and it float x to 5.2. What happens when I say this, cout I, and then x, and so on? How do I put many different arguments to my output statement, when we saw that basically, especially with the built-in types, it's a member function that takes only a single parameter as a right-hand side? How does that work? So the answer is, when I say cout I, and this is printing an integer into an OStream object, and that's built in, as we saw before, it's built into the OStream class. What happens is, it's going to print a 5, right, because I is 5, it's going to print a 5 to the output, but it's going to return the OStream object that I passed in. It's going to return as a value of that function cout, the cout object. So it did two things. It did something, namely it printed, but it also returned the value, which is cout. Now this cout is now going to be applied with the x, which x is now that float, and it's going to cause the 5.2 to print out, but it's going to return now also a cout object. This cout object is going to be now used to print the string hi. Right? And so it's going to put hi into the output, onto the console, and again it's going to return a cout, right? Because that's what it does. And then it's going to take the endl and put that into the cout object. It's going to cause the line to be next to the new line, and it's going to return a cout. And at this point, the cout is going to simply be ignored. But that's how we get this chaining. That allows us to chain each one of these things, first to print this, and then to print this, and then to print this, and then to do an end line, without having to use separate output statements. The same thing works when we want to print out a class object. right? So if we go back to the definition of the overloaded operator left shift, we can see what's going on over there. So let's check out what happens in this case here. So I declare my rat6 to have 1/2, and then I initialize to 1/2. I declare an integer I to be 5, float y to have 5.2, and now I say this output. So what happens here is just as we saw before. The first thing that happens is does a cout I. So I is an integer, so it's going to print out a 5. So 5 will be printed, but then it's going to return the cout operator. Now, which left shift is this? This is the left shift that's part of the OStream class that takes a cout object on the left-hand side and an integer on the right-hand side. But now what's going to happen is it's going to return the cout, but now the compiler is going to see my x. Right? It's going to say cout x. So which operator left shift is it going to call now? It's not going to call the same one for the integer. It's going to call the one that we just defined before that takes a left-hand side of an OStream object and a right-hand side is rat. In other words, it's going to return, it's going to use this one up here, the one we defined as a friend of our class. But when we wrote that, what's it going to return? It's going to return an OStream reference. It's going to return this OS object, which is what we passed in now, the cout. So cout comes back to that same cout as before, and now it's going to put a 5. So now it's going to print out the y, cout y. So which overloaded left shift is going to use now? Well, this again is like, it's not from the rat class, it's the one from the OStream class that has an overloaded left shift operator where the left-hand side is a OStream object and the right-hand side is a float. And then finally, this is going to return a cout. And now it's going to do an endl, give us a new line, return a cout, and that's the end of the story. Okay, now what about input? Input is pretty much the same thing. Right? So that's how input out works when you have to overload the operators.